Right, in this video I'm going to try to explain how earthing and how the earth wire in your plug and in your appliances that you use offers some protection against dying from an electric shock. It's quite tricky this, but we'll see how we get on. So we'll start where we left off during the lesson with this diagram, where over here we've got the power station, okay, producing AC, and we're going to skip out a lot of the stuff in between, okay. So your house isn't connected directly to the power station. There's all sorts of transformers in between, stepping up and stepping down the voltage, but that's sort of relevant for another lesson. So we've got the power station over here on the left, over here, your house is over here on the right, and they're connected sort of essentially by two wires, one which we call the live wire, and one which we call the neutral wire. But you'll know obviously from looking at plugs that inside your plug socket there are three wires: the live wire, the neutral wire, and also an earth wire. And the earth wire is all the earth wires in your house all connect together, and they go actually into the earth, into the ground over here. So this thing here symbolises your earth connection going into the ground, and these three lines here, like this, that's kind of like the symbol for earth, so, or ground. I also mentioned that at the local substation near you, okay, which is what this little dotted box here is, the neutral wire is also connected to the ground, okay. So the neutral wire gets connected to the ground somewhere near where you live. What is the point of all this, and how does it help you not die? Well, let's get started. How can current flow in this circuit from the power station through stuff and then back to the power station? Well, the way it's designed to work normally is that current flows through the live wire and back through the neutral. So ordinarily, if you plug something in your house, like a light bulb or something like that, it gets connected to the live and the neutral. Current flows in the live and the neutral wires, the light bulb works, and everyone's happy. However, that's not the only way that current can flow around this circuit. The ground itself, the earth itself, is actually conductive. It can conduct electricity. So another way that current can flow is through the ground to the local substation and then back through the neutral wire there. So if you were to connect a bulb to the live wire, okay, and then shove that into the ground, let's use the proper ground symbol, okay, poke a wire into the ground, that would work, okay. So current would be able to flow then through the ground to the local substation and then complete the circuit. So that would work. It's not the way the system is designed to work, but it would. So current can flow through the ground. It's just the ground, you know, might end up having more resistance than a copper wire. So this is the situation. This is how things are wired up. So we're just going to explore some possibilities, given that this is the situation, of what can happen. So first question is, what happens if you take the back off a plug or something like that, or you take an appliance apart that's plugged in to the mains and you touch the earth wire, okay. So here you are with long arms touching the earth wire. What happens if you touch the earth wire? Answer, hopefully not very much, okay, because the earth wire isn't, you aren't, by touching the earth wire, you aren't completing any sort of meaningful circuit with the power station, okay. You're just touching a wire that's shoved into the ground, and there may be another wire shoved into the ground somewhere else, this neutral wire here, but you're not forming any sort of complete circuit with that. So if you were to take an appliance apart and touch the earth wire, nothing is going to happen to you, okay. What about if you touch the neutral wire? So you've taken this appliance apart against, you know, all good instincts. You've taken something apart and it's plugged into the mains. You accidentally touch the neutral wire. what's going to happen to you? The answer again is not very much, because the neutral wire not too far away from you is connected to the earth anyway. Okay, it's connected to the ground, so it's at the same potential as the ground, which is what you are in contact with, by the way, all the time. Unless you're wearing some sort of amazing special insulating shoes, which you're probably not, then you're always in contact with the ground. Or unless you're floating or something, you're always in contact with the ground. So when you touch the neutral wire is connected to the ground anyway. So again, you're not forming any complete circuit with the power station. There's no major risk to you. So touching the neutral wire is not advisable, but it's not the end of the world. Touching the earth wire, that's fine. What happens if you touch the live wire and the neutral wire? Well, in this case, you are asking for trouble. Okay, if you touch the live wire and the neutral wire at the same time, especially with different parts of your body like this person is, then you're entering a world of pain, because now you've formed a complete circuit with the power station that current can flow through. So current is going to flow through you, through the live wire and back through the neutral wire, and this would be extraordinarily dangerous and result in terrible burns to that part of your body or death. So I don't recommend you try it. So touching the live wire and the neutral wire is a terrible idea. What about if you just touched the live wire? Just by accident, you just touched the live wire. You didn't mean to, but you did. Okay, you touched the live wire alone, not the neutral wire as well. Now, as I said before, you are rarely totally isolated from the ground. You might think you're wearing rubber shoes, and those rubber shoes are insulators, and the current can't flow through them, but it can, and it doesn't take much current to injure a human being. Okay, so we've already established that the ground conducts electricity, and we've established that the neutral wire here at your local substation is connected to the ground. So if you're in contact with the live wire and the ground, current can flow through you, through the ground itself, to the local substation, and then back through the neutral wire. So if you come in contact with the live wire and you are touching the ground, which you inevitably are, or anything else that is touching the ground, then you are also in for a very dangerous electrical shock, which could kill you without a doubt. So touching the live wire alone even is extremely dangerous. Okay, and this is where the earth wire comes in to protect you, because touching the live wire is very dangerous, so obviously no one does it. No one goes around deliberately touching the live wire in their appliance because it's so dangerous. But what if you had an appliance like this square appliance? Okay, maybe it's one of those posh toasters, okay, that's got a shiny metal case. Okay, it's got a lovely shiny metal case. Here's the wire that comes in. I'm drawing my live wires in red, by the way, because that's like the default colour that's available, but as you know, the live wire is brown. Okay, here are the wires coming in, and we won't draw the earth wire because we'll pretend it hasn't got one for now. Okay, now obviously no one goes around touching the live wire, that's a terrible idea, but what if in your lovely toaster, gradually with age, you know, the connections start to come loose, and the live wire accidentally comes loose, okay, and touches, whoops, put that down in the wrong place, and touches the metal case of the appliance. Okay, what does this mean? Well, obviously you're not stupid, you're not going to go around touching the live wire, but you might touch your toaster when you go to put toast in it, not knowing that the live wire inside it somehow has come loose and is now touching the metal case. Now, if you come to touch your toaster to put toast in it, and the live wire is touching the metal case of the toaster is very conductive. Current can then flow through the live wire, through the toaster, through you, through the ground, back to the power station. That's a complete circuit with the power station. And if you touched the toaster with the live wire touching the metal casing, you'd get a terrible electric shock. So this would be a very dangerous situation. Okay, so to prevent dangers like this happening, and you would never know, you know, no one's going to inspect their toaster every time they come to use it, you know, has the live wire done this or that, you know, you just use your toaster, you don't know whether this has happened or not. So to try and help prevent this risk, all appliances with metal cases have an extra connection to the earth wire. Now remember, the earth wire is green and yellow, I've only got green. The earth wire is connected to the metal case, and at the other end the earth wire is connected into the earth, okay, over here near your house. So now let's imagine the situation where the live wire has come loose and the live wire touches the metal case of the appliance. Okay. Now the instant that this happens, we've now formed a complete circuit already with the power station. So this, you're not even part of the equation here. The instant that live wire touches the metal case, we've formed a complete circuit, because the metal case is also connected to the earth wire. The earth wire is also connected to the earth. The earth can conduct electricity back to the local substation. So the instant this happens, we get a huge current flowing. If I come and draw it on this now, okay, now what we've done is essentially connected up the live wire with the earth connection in your house, okay, through the metal case of the toaster. When this happens, current can flow through the earth as well. There's hardly any resistance in this circuit because everything that's in this circuit is a good conductor. So when this happens, a large amount of current flows through the live wire and through the earth wire. And when a large amount of current flows through the live wire, the fuse blows in the plug, because inside all the plugs in our houses, okay, those 3-pin plugs, is a fuse that blows at whatever current rating it is. So when this happens, if the live wire touches the case, then straight away a large current flows through the live wire and back through the earth wire, and then the fuse in the plug blows. Now when the fuse in the plug blows, you remember that the fuse is connected to the live wire, okay, so the live wire then gets isolated. So even though it's still touching the metal case, it's been disconnected at the plug end from the live supply. So the toaster is now safe. So as soon as this fault occurred, the fuse in the toaster would blow, and the casing would no longer be live. So if you then went to touch it, you wouldn't die. You'd just find that your toaster was no longer working because the fuse had blown. So here's the key. So this is why we have earth wires and fuses in plugs, and it's a great protection against this sort of thing happening, okay? So anything with a metal case is very likely to be earthed, to have the metal case connected to the earth wire, and then that connects to the earth wire in your house that goes into the earth. Here's a list of, just, you know, to break down the steps of what happens, just so we're absolutely clear. So first of all, your appliance with a metal case is connected to the earth wire. So the earth wire is literally screwed somewhere onto the metal case, so it's electrically connected. If the live wire comes loose and touches the metal case, current can now flow through the live wire, then back through the earth. Okay, so a complete circuit is formed with the power station. There is very little resistance in this circuit, so a large current flows. Straight away, a large current starts to flow. This blows the fuse in the appliance's plug, and the appliance is now safe because the live supply from the plug has been broken. Okay, so this is how the earth wire protects you. Now, having said all that, not all appliances have an earth connection, and even some appliances with metal cases don't have an earth connection. They are what's called double insulated appliances, and they'll have somewhere on a sticker on them this, okay, symbol, double insulated. That means that wherever the live, wherever the connection comes into, it's so well insulated that there's no way that the live connection can ever come in contact with the metal case. I mean, most things that are doubly insulated don't have metal cases, but there are some things with metal cases that are doubly insulated. What it means is there's basically no chance of the live wire ever coming in contact with the case, so it's essentially, it doesn't need the earth connection from the case. But most stuff with a metal case does have an earth connection, as we have discussed it just there. So I hope that sort of helps to explain things a bit. You might still have some questions. This is quite a complicated topic, and you might be asking yourself all sorts of questions like, why do they bother connecting the neutral to the ground here anyway? Doesn't that cause more problems than it solves? The answer being no, it actually solves more problems than it causes, but it's complicated. And you might also be wondering, why do we need an earth wire? Couldn't we achieve all of this stuff by just connecting the neutral to the case. Wouldn't that work? Why do we need this whole separate wire? Surely it would be the same with the neutral connected. Well, it turns out it wouldn't, and we can discuss that in the lesson if you like, but it's probably a bit much for this video. So hopefully that's enough to give you an idea of how the earth wire helps protect you if you have appliances with metal cases.